Hey everyone, in this video let's look at how to solve this limit problem. First, let's take a look what will happen intuitively as x goes to infinity. So when x goes to infinity, x squared becomes a very large value, and the minus 9 becomes insignificant compared to how large the x squared will become. And the same with minus 6. As 2x goes to infinity, minus 6 also becomes insignificant. Therefore, we can kind of see our function the same as the square root of x squared over 2x. And square root of x squared, that is also gives us x over 2x. If x is any real number, then we can get the result will be 1/2. Does that still apply here as x goes to infinity? The answer is yes. You can think of it as you have something grow to infinity on the top, and on the bottom you're growing at a rate of 2. So here 1/2 is the growth ratio of top and bottom. So intuitively, we know the limit for this question is 1/2 as x goes to infinity. And now let's try to solve it in a more detailed way. So normally for a limit question, we want to plug in x goes to infinity. As we mentioned previously, we would get x over 2x. And when you plug in infinity directly, we get infinity over infinity. And that is called an indeterminate form, which means we need to think of other ways to simplify this function. And the key here is we want to factor out the highest power of x. So let's rewrite our function a little bit. On the top, we would have x times square root of 1 minus 9 over x squared. And on the bottom, we would have x times 2 minus 6 over x. And the next step is let's cancel out the common terms. Even though our x goes to infinity, but we can still cancel out the common terms when we have x both on the top and the bottom here. And then we know as x goes to infinity, 9 over x squared goes to 0. And 6 over x also goes to 0, because here our denominator becomes a very large value. Therefore, our equation becomes, on the top we have the square root of 1 minus 0, and on the bottom we have 2 minus 0, which gave us 1/2. And if you have learned derivative and L'Hopital's rule, you know this is also a good situation to use that, because we have an indeterminate form. So for L'Hopital's rule, we want to take the derivative of both the top and the bottom separately, and we would have the same limit value as our original equation. So the prime means we're taking the derivative of top and bottom. The derivative of the top portion we would get 1/2 times x squared minus 9 to the negative 1/2 power times 2x. Here we're using the chain rule to take the derivative. And for the denominator, we would have 2x, the derivative of 2x is 2, and minus 6 get cancelled. And let's simplify this function and see what we would get. We get x over 2 times square root of x squared minus 9. Because here we have a negative sign, so your x squared minus 9 becomes on the denominator. And here let's divide both top and bottom by x. We would get 1 over 2 times 1 minus 9 divided by x squared. And now we know as x goes to infinity, 9 over x squared goes to 0. Therefore, our function becomes 1 over 2. And what's inside the square root becomes 1. And this is the same answer as we calculated previously.